Hi, it's Mrs. Mays again. We're going to do some more chemistry. This time our video is going to focus on mixtures. Mixtures are any physical blend of two or more substances that are not chemically combined. So an example of different types of physical mixtures are heterogeneous mixtures and homogeneous mixtures, where in a heterogeneous mixture you can see different pieces just by inspecting the mixture. You might have to look closely, but you can definitely tell the different parts in a heterogeneous mixture. Some that are difficult to tell apart, though, are things called a suspension or a colloid. A suspension has larger particles and a colloid has medium-sized particles. And by medium, I'm talking on like between nanometer and micrometer. And then suspensions have particles bigger than a micrometer, so they're still not large. They're just classified as, larger or smaller. And then if we get too small, then it's really hard to tell the difference between any of the parts of your mixture, and it starts to look the same throughout. So if your mixture looks all the same throughout the whole entire thing, then we would classify it as a homogeneous mixture. And then here's where we get the smallest particles when we have something called a solution. Those particles tend to be smaller than 1 nanometer in diameter. Another type of homogeneous mixture is an alloy, where metals mix together so much that you can't tell the difference between the two. So bronze is a mixture between tin and copper. Another one might be sterling silver, where we can make the silver a little more durable and keep it from tarnishing if we mix it with other metals. Now, pure substances, remember, are not physically combined, but chemically combined. So a compound would have to be separated chemically, not physically. So one way to do this is by sending an electrical current through the substance. Like if we send an electrical current through water, then that's going to separate the hydrogen and the oxygen into bubbles of each different gas. And then precipitation is where a solid forms, because we can be careful. The solid has to form because of a chemical reaction, not because you've evaporated the liquid away. That's not the same thing as precipitation. And then, of course, the key here, if we are separating a compound chemically, we are breaking chemical bonds. So if you rearrange bonds between atoms, then you were not separating a mixture, you were separating a compound. Separating a compound requires bonds to break and reform in different ways. But let's look at separating a mixture, which has to happen physically. Oh, before we do that, let's decide what is a pure substance. We have some definitions here. So all of the samples of the substance would have the same proportion of components throughout the whole entire thing. And a pure substance is a material that has only one set of properties. So every piece of it's going to react the same way no matter where the sample is taken from. There's a conceptual definition too for a pure substance, a material that has atoms that are chemically combined in a fixed ratio is an example of a pure substance. So like water has 2 hydrogens for every 1 oxygen. carbon dioxide has 2 oxygens for every carbon, but carbon monoxide has only 1 oxygen for each of its carbons, and that's why carbon dioxide and carbon monoxide have such very different properties. A material in which the solid phase has only one pattern, like one crystal structure or one type of grouping of atoms throughout the whole entire thing, would also be considered a pure substance. Now, to decide whether something is a mixture, then we would look at the specific components within that material. So in a mixture, material has components that would retain their own individual identities and can thus be separated from one another. So the whole substance doesn't have one property. Each different thing in the substance has their own properties, and we can use those to separate them. And of course, if those same components can be mixed in different proportions, then that's not a compound, that's a mixture. Let's look at the conceptual definition. So a mixture is a material that is composed of more than one substance, and they are physically in the same space, in the same container, for instance, but they are not chemically combined with one another. So to separate a mixture, we would have a physical change to get each substance apart from one another. So we'd have to rely on the different physical properties of each component. For example, some components may have a different density, so we can use density to separate them. Filtration is going to separate things by their particle size. Centrifugation is a good example of a method of density separation. If I spin something really fast, then the heavier things go to the outer edges and the lighter things stay on the inside. Chromatography can separate different fluids, like if you have ink from a pen that's say it's a black pen, you can separate it into the different colors that make up that black because it's made of different pigments. Another handy way to separate things is called distillation, and I use a distillation apparatus in our lab to clean the water so that the water we use for lab doesn't have any ions in it. And froth flotation allows lighter things to float up at the top, or we add a coagulant so that they'll stick together but they won't stick to the rest of the stuff, so then we can skim them off when they're floating up to the top of our container. Let's look in a little bit more in detail. So to separate a mixture physically, we could use distillation to separate things that have different boiling points. So that's why I can get the water separate from the ions in the water. Things like calcium don't really boil at a temperature that I can heat things up to in the chemistry lab. So I can get the water separate from the calcium and sodium ions that are naturally occurring in our soils and tend to show up in our tap water. Flotation is the separation of insoluble solids. That means solids that can't dissolve in water, and we use flotation to separate them when they have different densities. So some things float up to the top and some things don't. Filtration helps us separate things that do dissolve, they're called soluble, from the things that do not dissolve, insoluble. So if I have a mixture of salt and sand, I can dissolve the salt, but I can't dissolve the sand, and then we can filter out the sand and then evaporate the water to get my salt back. And then fractional crystallization is the separation of two solids that do both dissolve, but we can use the solubility and the temperature to separate them because one thing will dissolve at a hotter temperature than the other. And once we get to cool it down enough, then one of the solid things will crystallize before the other. So we can use fractional crystallization where only a fraction of our solution turns into a solid again, and then we'll have the other substance still in there. And then finally, chromatography is the separation of two fluids based on how well they stick to some thin film, like a filter paper or some chemical coating that we put inside a tube. And I just want to define this term. Fluid means things that flow. So that could be either a liquid or a gas, because liquids and gases both have the ability to flow. So to separate a mixture, use the physical properties of the components inside the mixture to get them apart. So if we're looking at our concept map of how to classify matter, we have pure substances and we have mixtures. And we can classify homogeneous mixtures and heterogeneous mixtures in different ways, and you can subcategorize each of these. So in class, I'm going to ask you to create a concept map. You might as well get started and see what details you can fill in from your notes.